So, for about the last year or so, we've all kind of settled on one main way to build AI agents, a standard that let them connect to the outside world. But what if I told you that whole standard has got some pretty serious flaws? Today, we're going to dive into a huge shift in how we build these things, a move away from just talking to tools and towards something way more powerful, actually writing code. All right, here's the plan. We'll start with the promise of this protocol that got everyone so excited. Then we'll look at where the cracks started to show. After that, we'll get into the, honestly, pretty elegant fix. And finally, we'll explore the incredible new future this whole thing unlocks for the agent of tomorrow. Okay, so first up, the promise of MCP. To really get where we're headed, we've got to start with where we've been. And that means talking about the protocol that pretty much became the standard for everyone, the Model Context Protocol, or MCP. So, what is MCP? The easiest way to think about it is like a universal translator for AIs. Before MCP, if you wanted to connect your agent to, say, Google Drive or Salesforce, it was a totally custom job, every single time. What MCP did was create this one open standard so that any agent that speaks MCP could instantly talk to any tool that also speaks MCP. It's basically an API built specifically for an AI to understand and use. And honestly, this was a massive breakthrough. The real magic here wasn't just the tech itself, it was the fact that everybody started using it. It became the de facto standard. And that created this huge, amazing ecosystem where developers could just build and share tools, and suddenly your agent had access to this whole universe of integrations. And when I say people adopted it, I mean it took off like a rocket. Seriously, within just a few months, the community built thousands of these MCP servers. Pretty soon, you had developers building agents connected to hundreds, maybe even thousands of tools across all these different systems. It really felt like the golden age of agent connectivity. Or, well, so we thought. And that brings us right to part two, the cracks in the foundation. Because as these agents got more and more powerful and we plugged in more and more tools, some really serious kind of hidden problems started to bubble up. Okay. This slide right here, this visualizes the core problem perfectly. It's all about a massive inefficiency. On the left, you see what the agent actually needs. On the right is what MCP forces it to load. It's like, imagine you need one specific screwdriver from a giant toolbox. But instead of just grabbing it, you have to first read the entire instruction manual for every single tool in that box. That's exactly what was happening. And it really boiled down to two big problems. First, what we're calling tool definition overload. You connect your agent to a few hundred tools, and it has to stuff every single one of their definitions into its context window, every single time it runs, even if it only needs one. The second problem is intermediate results. Let's say a tool pulls a huge document. The entire document gets jammed into the model's context, just to get past to the next step. It's just so slow and unbelievably expensive in terms of tokens. So how bad was it? Well, this number says everything. Researchers found that by switching to a new method, you could slash token consumption by up to, get this, 98.7%. I mean, that's not just a little improvement. That is a total game changer. That's the difference between a project being totally doable or just way too expensive to even consider. Okay, so that brings us to the fix. And it's actually pretty brilliant in its simplicity. If the problem is making agents talk to tools through these super long, clunky definitions, what if we just let them do what they're already great at? Let them write code to use the tools directly. So what does this new workflow actually look like? It's basically a three-step dance. First, you just organize your tools as simple code files, like in a normal folder system. Super straightforward. Second, when the agent needs to do something, it just looks through the files to find the exact tool it needs for the job. And finally, step 3, it just imports and runs only that one specific piece of code, on demand. No more reading the entire library just to find one book. And this little table just makes it crystal clear. On the left, that's the old way, a simple tool call. On the right, that's the new way. The agent writes, a couple of lines of actual code to import the specific tool it needs and then run it. It looks like a small change, right? But that subtle shift has absolutely massive implications for how efficient and powerful these agents can be. And this is where it gets really exciting. Because this isn't just about saving tokens or making things run faster. This whole code-first approach unlocks a brand new set of capabilities. We're talking about creating a totally new kind of agent, the agent of tomorrow. The benefits here are just huge. You get progressive disclosure, which means the agent only finds tools when it needs them, not all at once. Then there's context-efficient results. This is a big one. An agent can take a giant spreadsheet, filter it down in code to just the 3 rows it cares about before that data ever hits the expensive context window. They can also use real programming stuff like loops and conditionals to handle way more complex tasks. And this is super important. For privacy, it can process sensitive data without that data ever leaving a secure environment. That's a massive win. But out of all of these awesome benefits, there is one that is, I think, the most game-changing of all. It's this idea that agents can actually develop and remember their own skills. So what do we mean by a skill? Well, picture this. An agent runs into a problem it's never seen before. It figures out a solution and writes a little function, a new piece of code to solve it. With this new approach, it can literally save that function as a file. So the next time it faces that same problem, it doesn't have to solve it from scratch. It just calls on the skill it already built. Think about that. The agent is no longer just doing tasks. It's actively learning, evolving, and building its own high-level toolbox over time. Now, we gotta be fair here. It's not all sunshine and rainbows. This new power doesn't come for free. The old way, the direct tool calls, it was simpler, no doubt about it. This new code execution method is definitely more complex. And, this is critical, it absolutely requires a secure sandbox environment to run that agent-generated code safely. So yeah, there's a bit more infrastructure overhead to think about. But this quote from Anthropic really just hits the nail on the head. It says, LMLs are adept at writing code, and developers should take advantage of this strength. And that's really the whole philosophy here, isn't it? These models are amazing at writing code. So instead of making them jump through all of these hoops, why not just lean into their biggest strength and let them code the solutions directly? So, are we saying MCP is dead? No, not at all. The future here is almost certainly hybrid. Look, for really simple, direct stuff, like, I don't know, sending a ticket from a form, the old way is probably fine. It works. But for those really complex, multi-step problems, yeah, code execution is, without a doubt, the much, much more powerful way to go. And that really leaves us with one final, kind of mind-bending question to chew on. We've just figured out how to let agents not just use tools, but create their own. So when these agents start writing and even sharing their own skills, what new things are they going to invent? What capabilities will they come up with that we haven't even imagined yet?